All right, we are going to kick things off with a GCF review. So this is something we've already learned, talked about multiple times, taken a quiz over. So our goal today is finding the GCF of two or more terms. Here's our first example. Remember, to find GCF, we need the prime factorization for both or all of the terms, and then we look for matches. So if I were to break down 6, I know that 6 breaks into 2 times 3. X cubed means I have x times x times x. Y cubed means y times y times y. If I'm breaking down 8, if I'm not sure what it is, we could do a factor tree. 2 times 4. 4 breaks into 2 times 2. Remember, we don't use anything we broke down. So 8's prime factorization is 2 times 2 times 2. X to the 4th. So 4 x's. Y squared. 2 y's, and z squared, 2 z's. Now that we have our prime factorizations, I'm looking for matches. So I have a match of 2's, 1, 2, 3 matches of x's, 2 matches of y's. So anything that matched up, I'm going to multiply together. So 2 x cubed, because there were 3 matches, y squared, because there were 2 matches, is my GCF. Remember, as I go through these videos, you can always pause them, stop them, rewind them, rewatch them. So if you need more time, just do that now. Next example. All right, on this one we've got 11xy cubed z squared and 17x cubed y to the 4th z squared. You might be able to just look at this and know that 11 and 17 are already prime numbers, so they don't have any common factors. So then we are just looking at the variable parts. If you really wanted to, you could say your GCF includes a 1, but that's not necessary. So we look at, let's do our x's first. Remember, if there's no exponent written, it's an exponent of 1. So this is x to the 1st. Here we have x cubed. Remember, they both have to be able to give up the same amount at the same time. So the most they could both give up at the same time is just going to be x. If you need to see that written out, you could do your lists x and then x times x times x, and we still just get that one match. For the y's, we do the same thing. They both have to be able to give the same amount. So this one has 3, this one has 4, so this one limits it. The most they could both give would be 3, so y cubed. On this one, the z's are pretty easy because they end up being the same. They're both z squared, so they could both give 2 z's. So this is my GCF for those terms. All right, if you have any questions, write them down and you can email them to me so I can answer them later. We'll move on to our next example. On example 3, we have 3 terms that we're looking for the GCF for. I'll go ahead and write out the prime factorization for the number parts. So if I'm doing the prime factorization for 45, well, I could break 45 into 5 times 9. 9 breaks into 3 times 3. So I would have 3 times 3 times 5. Okay, the other two both have 18s. So 18 breaks into 2 times 9. 9 breaks into 3 times 3. So both of my other two lists would have 2 times 3 times 3. Okay, we could write out the variable parts too if you want to. If you need to see it, we can put it there. All right, so we've got them all the way factored. We're looking for our matches. So it looks like we've got a match of 3s here, a match of 3s there. We've got a match of x's, a match of y's, and then that looks like that's it. Even though we have some other matches between 2 of the lists, if it's not on all of the lists, it won't work. So we're going to be taking 3 times 3 times x times y. Of course, 3 times 3 is 9 xy. So that is my GCF. Again, if you don't need the lists to be able to see that, that's fine. If you can see that the x's get limited by these first 2 terms, fine. The y gets limited by the last term, and the other 2 terms don't even have z's. All right, we've got one more example to do together today. Again, I'm going to start out by writing the prime factorization just for the numbers. So if I'm breaking down 24, 2 times 12, 12 breaks into 2 times 6, 6 breaks into 2 times 3. Don't use a number that you broke down. So 2 times 2 times 2 times 3. 33, that one should be easy. You're only going to break it into 3 times 11. And 6, also pretty easy. You can only break it into 2 times 3. So just looking at the number part of this, the only thing they have in common is a 3. Some of you might have known that right away just by looking at this problem. So we know 3 is part of our GCF. You should be able to look at this and know that x can't be part of your GCF because this first term doesn't have any x's to give at all. So if one of the terms doesn't have it at all, it won't be in your GCF. If we look at our y's, this one has y to the first, the middle term has y to the first, the last one has y squared. So they all could give up 1y at least. So that's the only thing they have in common. And then also with the z's, this last term doesn't have any z's at all, so therefore the GCF does not include a z. So 3y is all I have for my GCF. Again, this should have been a review. If you want to list out your variables like we did on the first 3 to find your GCF, that's fine. If you have any questions at all, please make sure you're communicating those to me from email, Hangouts, Google Classroom. Please, please, please make sure you're keeping up with this and reaching out. I will have a homework assignment posted as a Google form that you are expected to complete. Those responses will get submitted to me. All right, so if there are no questions, then I will just see you tomorrow.